Okay, in this video we're going to be looking at combination of radical terms. This is going to be part one. Now, in this video I've got several examples and I'm trying to illustrate the property of exponents, which says when you have the same base you add the exponents of the bases or multiply by each other. That tends to confuse students at the start whenever they see them in terms of radicals, but remember, the rules for exponents apply all the time, no matter how ugly the exponents get. If the exponents are fractions, you follow the same rules. And if you keep that in mind, that'll make this unit of homework a whole lot more easy for you. Okay? First example I have for you, we have the fourth root of 7z minus the cube root of 7z. And you'll see a problem very similar to this in your homework, more than likely. And the key here is, yeah, you have the same base, you have different exponents. You could think of this as the quantity 7z to the 1/4 power. Think of this as 7z, that quantity, to the 1/3 power. But the thing that throws this off is there's a minus sign here. Guys, you can't add or subtract exponents that are, you can't add or subtract terms that aren't alike. And that's what this is talking about. So this guy right here is as simple as possible. What I abbreviate as SAP, S-A-P, simple as possible. Now, the second example, b to the 2/3 times b to the 5/7. Well, now there's multiplication there. That means we add the exponents. So this is the same thing as b to the 2/3 plus 5/7. And don't forget, you got your calculator that can add or subtract fractions for you. If you don't have one handy, then to add or subtract fractions, you need a common denominator. The least common denominator between 3 and 7 is 21. So I needed to make this 3 into a 21. I multiply by 7. 7 times 3 gives me 21. 7 times 2 gives me 14. Multiply the 7 by 3, that gives me 21. 5 times 3 is 15. And then I add the numerators together, so that's going to give me, my base is still b. 14 plus 15 is 29, and that gives me 29 over 21. Okay? Now, I want you to be polite mathematicians, and polite mathematicians answer the question in the same form they got the question. If the question was given to you in fractions, your answer should be in fractions. If the question was given to you in decimals, your answer should be in decimals. If the question was given to you in exponential form, your answer should be in exponential form. If it was given to you in radical form, your answer should be in radical form. So in this case, the answer of b to the 29 over 21st is correct, and it's polite. So that's the one we want. All right? Now, the next example. It's basically the same problem as this. It's just written a little bit differently. We have 3, the cube root of 3, or 3 to the 1/3. We have the 9th root of 3, or 3 to the 1/9. At first glance, it seems like it's like this one, as simple as possible. But because of the multiplication symbol, instead of addition or subtraction, it's not. We can do a little bit of work on this. I think it's simpler to think of these in terms of fractional exponents. So I want to write this as 3 to the 1/3 power, that's the cube root of 3, times 3 to the 1/9 power. Now, it does pay to notice that the bases are exactly the same. If this had been 3 and this had been 4, there's not much we can do with that. But because they are the same base, we can do the same thing we did a while ago. So this is really nothing more than 3 to the 1/3 plus 1/9. And once again, we need a common denominator to add or subtract fractions. Between 3 and 9, the least common denominator is 9. I have to multiply 3 by 3 to get 9, so 3 times 1 is 3. 9, I've already got it, so I just put a 1 there. So this turns into 3 to the 4/9 power. Now, once again, we're heading for polite mathematicians. The answer was given to us in radical notation. Our answer should be in radical notation. So, I want to write this as the 9th root of 3 to the 4th power. And if you think about it, 3 to the 4th is really 81. So this is going to be the 9th root of 81. And that'll be the answer that they want in the software. Not only that'll be the answer I'd want on an exam or a quiz. Okay, I guess it's the fourth problem. We're talking about the cube root of y to the 10th times the 9th root of y to the 6th. Now this is really the same problem as the previous two examples, except this one's a little bit easier, and I want to show you the shortcut here. If you think about this in terms of the way we did the first two, this turns into y to the 10^3 power times y to the 6/9 power. And keep in mind, these fractional exponents are fractions. You can reduce them. 10^3 is in lowest terms, is an improper fraction, which means we could simplify this radical. But 6/9 is a proper fraction. The top is smaller than the bottom, but it's not in lowest terms. This turns into y to the 10^3, I'm just leaving it alone for the moment, times, now 6/9 in lowest terms is going to be 2/3. And in this case, they were actually nice to us, because we have a common denominator. This turns into, using our laws of exponents, 10^3 plus 2/3. 10^3 plus 2/3 is 12/3. We have a common denominator. 12/3 gives us y to the 4th power. In this case, your radical symbol went away, so that answer is as politically correct as we can get. All right? Now, the final example in this video is really pretty simple also, but it tends to throw students for a loop because they have a hard time saying, well, this is the same type of problem as this problem or this problem or this problem. But it really is, because 5y to the 4th plus 2 is just some number. You may not know what it is, but it's just some number. The kicker here is that 5y to the 4th plus 2, this base and this base are exactly the same. So you simply add the exponents. We're going to write this as our base, 5y to the 4th plus 2. Exponents like this, when you have one number times another number, same base, you add the exponents. This is going to be 4/3 plus 5/3. Once again, they were nice to us, gave us a common denominator. We can just add those two up. 4 plus 5 is 9. 9/3 is 3. So our final answer here is going to be 5y to the 4th plus 2 to the 3rd power. Okay? Just because you have fractions in the problem to start with doesn't necessarily mean that you're going to have fractions in the end. Okay? Sometimes, like these last two examples, the fractional exponents turned into whole numbers for us. It's what I call pretty problems. All right? They're not all pretty, but a lot of them are. Okay? So, good luck. Go do some math.